It was good. So continuing on with atomic and molecular structure, let's get into it. So this is general chemistry. What is Dalton's atomic theory? So there's 4 points that make this up. The first point is that elements, like atoms of the same elements, will be like have similar properties because they're like the same thing, right? Damn, bro, I already forgot the other four, bro. The other three, bro. Okay, all matter is composed of atoms. Atoms are indivisible. Atoms of specific elements are identical in mass and properties. Compounds are formed by whole number ratios or two or more different atoms. A chemical reaction is a rearrangement of atoms. Damn, bro. What makes up an atom? Well, there's subatomic particles. There's electrons, protons, and neutrons. What is the inner core called? That's called a nucleus, and it's composed of protons and neutrons. Mass of each subatomic particle. So protons and neutrons are about 1 AMU. Electrons' mass are negligible. Like negligible or negligible? I don't know. When is an atom most stable? When it has like a full outer shell of electrons, so a full valence shell. What particle participates in bonding? Electrons. Valence electrons will participate in bonding. Atomic notation, which goes where? So we have the chemical symbol on the right. So like xenon, for example. Then we'll have the atomic mass on the top left of it, and then we'll have the atomic number on the bottom left of it. Let me just make sure. Yeah, mass number on the mass number on the top, atomic number on the bottom. Yep. Okay. What is an element defined by? So if you can change it, what do you get? So protons are what defines an element. So if you change the proton, you'll get a different element. If you change the other particle, so if you change the neutrons, you're going to get isotopes. So those are like the same elements, just differing in the number of neutrons. If you change electrons, you're going to get ions. You're going to get cations and anions. Cations are positively charged ions. Anions are negatively charged. Anions arise when you, when an atom like gets an extra electron, because electrons are negatively charged, so it becomes more negatively charged. It becomes an anion. Cation, it loses electrons, so it becomes positive. Okay, what are elements? Elements are just elements, man. Like what? Element is a pure substance. Compounds are not pure. Compounds are composed of elements. Okay, so it says elements cannot be broken down into other substances through physical or chemical changes. Okay. And then compounds are formed when two or more atoms from different elements combine. So elements are just the pure substance, bro. It's just one type of atom, and they're just pure. Then compounds are formed when two or more atoms from different elements combine. Okay, what are the two types of change? Physical and chemical. So physical is just, the physical properties like melting, boiling, or like crinkling up a paper, stuff like that. While chemical is like changing the bonds, like altering the bonds. So it's like burning a piece of paper or forming a precipitate or something like that. 5 types of reactions. So there's synthesis, like normal. Then there's single displacement, where it's like it's just you replace one of them. Then there's double replacement, which is when it's like they just both switch with each other. There's combustion, which is when something will react with oxygen and form CO2 and H2O. I mean, if you're reacting with a carbon molecule. And then there's decomposition, which is just breaking it down into two. Yeah, synthesis, decomposition, single displacement, double displacement. Oh, it's double displacement, not double replacement. Okay. Combustion reaction. Okay. It's quite simple, I would say. What is Heisenberg's uncertainty principle? You can never know the momentum or the position of an electron at the same time. What are the addresses of electrons called? That's called like the electron configuration or the quantum numbers. Yes, quantum numbers. Okay, so now what are the four quantum numbers? So we have the principal quantum number, which is denoted with n. We have the like orbital shape, which is L. The range of the range of n is 1, 2, 3, 4, like going up. It can't be 0 because n is depicting like what level the electron is on. You can only have like a 1 level electron, 2 level electron. You can't have like a 0 level electron. Then L is given like the shape of that, so it's like SPDF, and the range of L values it's n minus 1, and it must be greater than 0 because if you have like n equals 1, that's the lowest value you can have. Minus 1 is 0, so you can have L equals 0. Then 2 minus 1, 1, so you can have 1 or 0. Then like 3 minus 1, so you got 2, 1 or 0 for values of L. Next is ML value. That's the orientation of the orbital. So like for example, for let's say p orbital, that would be p orbital. P orbital would be the p orbital would be wait what the p orbital is L equals 2, so that means you can have 2, negative 1, 0, 1, or 2. So 5 different orientations. Wait, I feel like I'm getting something wrong. For p subshells, S is 0, P, okay, P is 1, so then it would be negative 1, 0, and 1. So that would be the ML value. Then you have the MS value, which is the spin. That's just saying the orientation of the spin of the electron in the orbital, and they have to be like opposite spins because that's just a rule. I don't know whose rule that is, but yeah. Okay. How many electrons are in each orbital? 2 electrons. Oh, wait, no, that's wrong. We're looking at like s orbital, p orbital. Okay, so in the s orbital there's 2 electrons, in the p orbital there's 10 electrons, in the d orbital there's 6 electrons, and in the f orbital there's 14 electrons. What are exceptions to regular configuration Y, and which specific atoms follow it? Okay, so one exception is chromium. So if you look at the periodic table, you'll realize that chromium is 4s2, and then it has 4 electrons in the d orbital. Now there's 5 orbitals in the d orbital, so rather than saying 4 half-filled electrons, chromium is going to take an electron from the 4s2 and put it into the 3d4, and it'll make it like 5 half-filled, and then it'll just be 4s1. So the chromium electron configuration, rather than being 4s2 3d4, it'll be 4s1 3d5, because you're just moving an electron from the 4s to the 3d. Now for that, molybdenum, that also follows the exception. Then the other exception is kind of similar. It's copper, silver, and gold, because copper has 9 electrons in the d orbital, so it'll have only 1 unpaired electron until it gets to a filled orbital. So copper, silver, and gold will all take an electron from their s orbital to make it a full orbital for the d, like a full d orbital. So that's like the exceptions. And then I just said what atoms follow. Okay, what are ionic bonds? Okay, this is kind of similar to biochemistry. So ionic bonds are just when complete electron transfer from one atom to the other, usually between nonmetals and metals, because that's like the highest difference in electronegativity. 4 properties of ionic compounds: they have high melting and boiling points, they conduct electricity, they form crystalline structure. Okay, let me restart. They form crystalline structure, they have high melting and boiling points, they conduct electricity, and I believe the other ones, they're soluble in water. Let me just make sure. High melting, boiling, soluble, conduct electricity, and they form crystalline structure. Okay, what are covalent bonds? 3 properties of covalent bonds. They they have low melting and boiling points. They they're not soluble in water very well. Or are they? No, they're not. They have low solubility in water, and they do not conduct electricity. It's just the opposites of the. It's just the opposite. Oh, also water covalent bonds, just the sharing of electrons. It could be polar or non-polar. It happens when the electronegativities are pretty similar to each other. Let me just make sure the properties. Lower melting and boiling point, insoluble, and do not conduct electricity. Yep, okay. Next, what is the covalent network of solids? So it's just like when covalent bonds within a molecule just become a network, right? Like that's what I understand. It doesn't include it in the notes, so I'm assuming that's maybe not that important. Oh, no, it says right here. Two types of compounds that use covalent bonding, covalent network solids. So that's like diamond and quartz. They're held very tightly. So all I need to know probably is just like atoms covalently bonded into a network. So it's just like a crystalline structure kind of, but like this is strong, you know? Yeah, okay. What are I forgot about the three characterizations of covalent bonds. Oh wait, I'm going, okay, wait. There's three characterizations of covalent bonds. There's bond length, bond strength, and polarity. Wait, bond energy, bond length, and polarity. Okay, bruv. This is so annoying. There's 38 pages in these notes? What? Okay, let me just lock in, bro. Okay, characterizations of covalent bonds. There's bond length, bond energy, and polarity. So bond length, that's like the distance between the two the atoms, right? Like the nucleus, the center of the atoms. So if you have a larger atomic radii, then there will be less attraction and less bond strength. Right. Bond length describes the distance between the nuclei of each atom. This broad shortens as the number of shared electrons increases. Therefore, a triple bond would be shorter than a double bond, which would be shorter than a single bond. So if you have more bonds, then it's shorter. Okay, that's like common knowledge, bro. So it's just the distance between the two nuclei. So then bond strength is how strong it is. So if you have single, double, or triple, damn, this kid just chased a rabbit, bro. Just allow the rabbit to live, bro. Yeah, so bond energy is the amount of energy needed to break a covalent bond. So yeah, having a triple bond will require more energy. Polarity, that depends on like the polarity, bro. If the a more electronegative atom will take the electrons and form the partial negative side, while the other one will form the partial positive side. So yeah. Unequal sharing equals polar. Partial positive charge, then you get a partial negative charge. That's pretty chill. What is coordinate covalent? That's a good question. Utilized as a type of covalent bonding whereby both electrons involved in the bond come from the same atom. What? Okay, so it's like the lone pair will combine with it. Okay, that's something like I learned in organic chem. Okay, so instead of sharing of electrons, it's just they share, but one of them is just doing all the sharing. So one way to think of this is like money. It's like this, the housewife and the husband. Like if the husband, or it could be the house husband and the work wife. You know, like I'm not saying that that's the genetic roles, but it's like if the husband's making all the money, then they still both share the money, right? Or it's like for a covalent bond, that's like sharing. It's like I don't even know what I'm trying to say right now, bro. I'm so tired, bro. of my head now. Okay. How do metallic bonds work? Metallic bonds work through like the valence interaction of the two metal atoms. Valence shell of a metal atom overlaps with the neighboring atom's valence shell. They're loosely held, gets delocalized, and becomes a sea of electrons. I remember that. Metallic bonds arise from electrostatic forces. Okay, so because the electrons are delocalized and in C, there's going to be the negative and positive, and then they'll just be attracted to each other. Okay. Damn, bro. My eyes are fried, bro. 4 properties of metallic compounds. They're malleable, they're ductile. Damn, why is this kid just running on the street? Malleable, ductile. So what does malleable mean? Could get hammered into shape. Ductile means they could be spun into wires. They conduct electricity, and they are lustrous, meaning that they're shiny. That was something from the previous biochem as well. 4 intermolecular forces. There's LDF, London dispersion forces. There's dipole-dipole. Then hydrogen bonding, and then the 4th one was something else, which I do not remember. It was a special one. Ion dipoles. Wow, I forgot to start the ones that I didn't know. I feel like I'm okay with most of them. I think I reviewed way too much content today, bro. There's no way I'm retaining all of this information. Okay, anyways. So the 4th one was, what was it again? Ion dipole. So what is each one? Well, London dispersion forces occur because electrons float around atoms like planets in the solar system. So at a time, there could be a positive side or a negative side depending on where the electrons are. Now this will induce a partial positive and a partial negative for a temporary amount of time. That'll cause the neighboring atom to also follow suit with that, and they'll be attracted, and it'll just be a reaction chain throughout all of the atoms, kind of. Hydrogen bonding is a type of covalent bond. Wait, is hydrogen? No, hydrogen. Hydrogen bonding is a type of dipole-dipole, right? Yeah, okay, hydrogen is not a covalent, it's a dipole-dipole. So I'll just talk about dipole-dipoles first for a minute. So dipole-dipole is when two molecules are two molecules are polar, so they got a partial negative, partial positive, and then those two sides will be attracted. The difference between LDF and dipole-dipole is that LDFs are temporary part, and then dipole-dipoles are like permanent. Then hydrogen bonding is a type of dipole-dipole, as in like hydrogen's bonded to a highly. But I just realized we still have a Christmas lights on. It's April. I think I should probably do that. I'm usually the one who puts them on. Anyways, what I was saying, dipole-dipole or hydrogen bonds are a type of dipole. Bro, how many times? Okay, hydrogen bonds are a type of dipole-dipole connection, attraction. So what happens? Happens when hydrogen is bonded to a highly electronegative atom, such as fluorine, oxygen, or nitrogen. That'll cause an induced partial positive side on the hydrogen. Then that hydrogen will get attracted to the induced negative of another one, and it'll just be connected. So yeah. Then ion dipole is just like the ion gets like if you put like sodium in water and then you put chlorine in water, like that ion will get attracted to that negative charge. Like, it's like instead of having two dipoles, you have one of them being an ion, and then you put the dipole in, and then it's like you get ion dipole combination. Let me just do this. Yeah, ion and a polar molecule. Yeah, so it's like the reason that's when you put NaCl in water, the Na plus side will get connected to the OH, like the N, like the H2O, like the oxygen, the negative side of the oxygen, of the H2O molecule, and then chlorine being the negative will connect to the positive hydrogen atoms. So that's what it means by ion dipole, because Na and Cl, like, so like H2O is the polar, Na plus is the ion, and like chlorine is the Cl minus is the ion, H2O is the polar molecule. Damn. What are the effects of increasing and decreasing intermolecular forces? So first of all, when you increase intermolecular, that means viscosity reduces. So, like the ability to flow will be worse. When you increase, also, you'll have a higher boiling point and melting point. When you increase, you'll have lower vapor pressure. What is vapor pressure? Okay, wait, maybe if I explain the other point first. So you also have higher surface tension, and then that also leads to lower vapor pressure. So surface tension, what it means, like the layer of water or the layer of a liquid is more like tightly close together, like they're stronger, right? So then it's like harder to overcome that force, like that intermolecular force. So now vapor pressure is like, because that surface layer is strong, then it's harder for them liquids to like get into gas form because they're strongly binded to each other. So then it's like, boom, there's less gas above it, and then there's less gas pushing on the liquid, so there's less vapor pressure because there's less molecules putting pressure. You know what I'm saying? Wow, I am like, bro, I'm not explaining these that well. Okay, what's the octet rule? Like usually every atom wants to get to 8 electrons as the valence, so it's like stable. What are the 3 exceptions plus examples? So the first exception is hydrogen, helium, lithium, beryllium, and boron and aluminum. These, it's like they're not able to get to 8 electrons. Like hydrogen only has 1 bonding electron. So then if it bonds to another thing, it'll only have 2 electrons. That's not close to 8 electrons. So it's not going to be fully octet, Lithium only has 3 electrons, 2 of them being inner core electrons. So 1 electron will be bonding to it. It'll not be able to stabilize into a full octet. Carbon, boron as well. Boron has it'll have 2 inner electrons and then 3 outer, right? So if you have 3 outer, you have 2 times 3 is 6. You're not going to be able to get to that 8 electrons. Now if you go to carbon, right? Carbon has 4 areas to bond, 4 bonding electrons. So then if you multiply by 2, 8 electrons, it'll be able to get that stable octet. So that's why carbon is not included. Aluminum is the same story as boron. It'll have 3 areas to connect. So then it'll only have 3 times 2 is 6, and it won't work. So then why does gallium work? Actually, I want to switch that up now. Why doesn't... I don't know if this is like a dumb question. It says it works for the... It says it's electron deficient. Interesting. There's a Khan Academy video. Perhaps I should watch this. Oh, bro, I'm not trying to give you a gift, bro.
Are talking about exceptions to the octet rule, which we've talked about in many other
I'll just watch this afterwards. Or maybe it says in the notes. Okay, yeah, it says boron and aluminum can share 3 electrons, and so they form only 3 bonds, so they only have 6 electrons in their outer shell. So can gallium just make more bonds then? Probably because it's... I'm not getting it, bro. Why can't gal... Oh, maybe... I don't know. I'm not sure. Okay, anyways, I'll move on. There's the exceeding octet. So atoms with a d orbital, they can exceed. So like phosphorus, sulfur, anything below that, they could just, exceed that 8 electrons and just form 5 bonds and have 10 outer shell electrons. So that's something. And then the other one is there's like an odd number of electrons. So some atoms, they'll just be able to hold a single electron. So it'll be like 7 or something like that, or 11, or I mean, like something, like 5 electrons. It's just what happens, bro. It's just sad, bro. It's like they're just not able to have an even number of electrons, so they have to divide it unequally, and it's just very sad, bro. Okay, what atom is usually the central atom? The less electronegative atom. Formal charge formula. So we got the valence electrons minus the lone pair, like the lone pair electrons minus the number of bonds. What is hybridization? It's the combination of 2 hybrid. It's like, bro. It's like when you who's playing basketball? It's like when you combine 2 orbitals and then they become hybridized into like one big, like they just become one, bro. Bro, I'm so tired, bro. Why are we talking about azimuthal? Oh my god, oh my god. How did you do that? Where does it talk about hybridization? Formal charge. Molecular orbits. I feel like I understand most of this because like I learned this already, so it's pretty chill. Okay, hybridization. Oftentimes, atoms do not directly form bonds with their atomic orbitals. Rather, they undergo hybridization to form new hybrid orbitals, which are a mix of existing atomic orbitals. So they mix. Since hybrid orbitals have better overlap, they form stronger bonds. Okay, so hybridization is just the mix of atomic orbitals, so they overlap more and then they become stronger. What are electron domains? It's just like the number of areas the electron can be. So like, so like the important thing to know is that like if you have a double bond, that's still one electron domain. What is the hybridization of single, double, triple bonds? So single bonds are sp3, double bonds are sp2, and triple bonds are sp. What is the formula for bond order? What does it correlate to? So bond order is anti-bonding electrons minus bonding electrons divided by 2. Should be here somewhere. Yeah, bonding minus anti-bonding divided by 2. What does it correlate to? It correlates to the number of double and triple bond. It correlates to the number of pi bonds, I think. Recall bond order refers to the number of bonds. So if you have bond order equals 2, then you have a double bond. What does pair and diamagnetic mean? So paramagnetic means you have unpaired electrons. That means you get attracted to a magnetic field. Diamagnetic means you have no unpaired electrons, and then you you get affected by a magnetic field. They're not attracted to a magnetic field, right? So paramagnetic, they are attracted to a magnetic field. Bro. Bond strength is affected by atomic radius, bond length, number of bonds. So bond order, that's bond, like number of bonds. Polarity, I don't know this one, bro. Okay, polarity, lone pairs, bond order, so like number of bonds. So bond order, how does it affect it? If you have a higher number of bonds, then you're going to have higher strength because the atomic radius, the bond length will be shorter as well. So they're close together. Atomic radii, if you have large atoms, the bond length, like the two nuclei will be farther apart, so it will just become weaker because there's less overlap of the orbitals. Polarity, if you're like not that polar, then you're not going to have that much attraction to the negative side of it. Like if you're positive and you're not that positive, then you don't have that much attraction to the negative. I think that makes sense, right? The greater the difference in electronegativity between the two atoms, the stronger the bond. It's because a large difference in electronegativity results in a polar bond. Yes, if you have partial charges, they have electrostatic attraction, and that will increase the strength of the bond. So, okay, so having more electronegativity will lead to more polarity, and that will be a stronger bond. Okay, so I was completely wrong. Okay, I understand it now. Lone pairs. So if you have lone pairs on one of the atoms and lone pairs on the other atoms, those lone pairs, those will like repel each other, and then that'll just put strain on the bond, and it'll just not be good because it's like kind of pushing apart. Okay, last one. What does VSEPR tell us? VSEPR tells us the geometry, like the shape, the geometry of a compound, like the placement, the spatial arrangement of those electron areas, like those electron domains, based on like how many there are and stuff like that. So what are the 5 main geometry groups plus the angles? So the 5 main geometry groups, there's linear, bent, tetrahedral, trigonal, pyramidal, and octahedral. I'm pretty sure those are like the main ones. So wait, let me just make sure. Oh wait. Linear, trigonal, planar, tetrahedral, trigonal, bipyramidal, and then octahedral. One, two, three, 4, 5. Oh wait, I forgot trigonal, bipyramidal. How could I ever do that? Let's just go one by one. So if you have 1, then it's linear. If you have 2, then it's trigonal, bipyramidal. If you have 3, it's tetrahedral. If you have wait. No. Yo, I'm on the wrong number. But okay, if you have two attachments, 2 electron domains, you're gonna have linear. If you have 3 electron domains, you're gonna have trigonal, bipyramidal. If you have 4 electron domains or 4 areas for electrons to be, you're gonna be tetrahedral. And then if you have 5, you're gonna have trigonal, bipyramidal, and if you have 6, you're gonna get octahedral. Electrons will just orient themselves in a way so that they're farthest away from each other. So for linear, you got 180 degrees. For trigonal, for trigonal pyramidal, you're gonna have 120 degrees. For tetrahedral, you're gonna have 109.5 degrees. For octahedral, for trigonal bipyramidal, you're gonna have. Wait, what is that? Oh, you're gonna have 120 degrees on the triangle place, and then you're going to have 90 degrees on the triangle to the pyramid stuff. And then octahedral, you're just going to have 90 degrees, 90 degrees, 90 degrees. So, yeah. Yep. Okay, so now what are the two shapes of sp2? So if you have, what is sp2 again? So that's like when you have two. So wait, that's when you have 3 electron domains. So you have 3 places for the electron to be. So that means you could have trigonal pyramidal. If you just have three like atoms, then you could also have 2 atoms and 1 electron. You have 2 atoms and 1 lone pair. That will lead to a bent or V shape. Okay, sp3, that's like 4 things. So you could have, so four atoms will lead to tetrahedral. 3 atoms plus 1 lone pair will lead to T-shaped. Right. Wait, no, bro. What am I even saying, bro? Okay, if you have, well, that's dumb. That was dumb. Okay, ignore what I said. So you have 4 attachments. So you have 1 atom. So 4 attachments, you got tetrahedral, right? So then if you remove one of those atoms and you add a lone pair, you're going to have trigonal pyramidal, right? That makes sense. Okay. Now, if you remove 2 atoms and you keep 2 lone pairs, you're going to get bent or V-shaped. That's 3 shapes. Okay. sp3d, so you have 1, 2, 3, 4, 5 attachments. So regularly that would be trigonal bipyramidal. If you remove one atom and you put in 1 lone pair, you're going to have 4 atoms and 1 lone pair. What would you get? What would you get? Seesaw. Okay, now remove 2 atoms, so you're left with 3 atoms and 2 lone pairs. You're going to get T-shaped. And now if you have 2 atoms and 3 lone pairs, you can have linear. That's 4. 3 shapes of sp3d2. So you have 6 attachments, 6 areas for the electrons to be, so that would be octahedral. After that, you can have square pyramidal. Is that a thing? Yeah, square pyramidal. And then you can also have square planar with 1 electron group on the top and 1 electron on the bottom. Lone pair group, I meant. So, yeah, that's honestly all. Like, it's important to note that, like, depending on the geometry, you could have different polarity. Like, if you have a square planar and all of the things are the same attachments, then they're all pulling at the same amount. They're polar, and then it'll just like net dipole will cancel out. Or tetrahedral. What? Yeah. Hopefully that made sense. Goodbye.